the Newton-Raphson'S formula, we want to show that this one is given by the cube root. It is going to be 2 out of 3 into xn plus n out of 2 xn power 2 for n equals to 0, 1, 2 onwards. Roman 3 n power, and here we can say the fourth root, and we want to show that it is given by xn plus 1 is given by 3 out of 4 into xn plus n over 3 xn power 3 for n equals to 0, 1, 2. Then Roman 4, I want to show the one for n, and this one we call it the fifth root. We want to show that is given by xn plus 1 is equal to 4 out of 5 into xn plus n out of 4 xn power 4 for n equals to 0, 1, 2, like that. So we can derive for the cube root, power quarter, power fifth, 1 over 6, etc. So let's try to check for the Roman 2, and when I finish Roman 2, it is the same process we had in Roman 1. I expect the candidates to now finish the remaining. So we are going to obviously let our x to be the n power 1 over 3, followed by powering 3 on both sides, which is giving us this, followed by trying to bring all the terms to the left hand side, and this is followed by letting our f of x to take on the x power 3 minus n, and the derivative of f with respect to x follows, which is the 3x power 2, and this is a 0, and then we now put xn for this. So this will be this n minus this, then the derivative xn will be 3xn squared. So these functions here that we have obtained, we are now going to deliver them in the formula, which says that xn plus 1 is xn minus the f of xn divided with the third derivative of xn, and then we are going to have this as xn minus f of xn is here, which is xn cubed minus the n, and we are dividing this by the 3xn but power 2. Now at this moment we can take our usual way of simplifying. The LCM will be taken, and the LCM is 3xn squared. This one divided by this, you get this, multiplied by that, the powers add on x, and that will be 3xn, so it is now power 3. Then minus this divided by that is a 1, so here we have just xn power 3 minus n. Check out how you expand this negative. Many candidates have a challenge. So this is xn plus 1 equals to, when I expand this one minus this, it will be just 2xn power 3, and this negative and this negative, we are going to simply have positive n like this, and then here we are going to have 3xn power 2. Now this function here can be simplified in such a way that this one is going to give us, I believe we can, according to the proof, we can remove out 2 up here. So when I remove a 2 up here, we are going to have 2 into, this one will now be xn power 3 plus, when I remove the 2, here I now have n out of 2. But the whole of this to power divided with this, power this. Now when we transfer this to the next solution, we are going to simply have we are simply going to have xn plus 1 giving us the 2 which we have. There is a 3 down there. So inside here we are now having here xn power 3 plus n out of 2, but we are dividing this now by xn but squared. The 3 has come this side. Now when I try to distribute this, when I distribute this one here, we are going to have 2 out of 3 into xn cubed out of xn squared plus n over 2 divided by this. These are 2 divisions. This one divided by 2, then divided by this. This one will simply multiply the denominator here, and we have it as 2 xn squared. When I try to simplify, this is 2 out of 3. This one divided by this, laws of logarithms, these are same bases, and the powers on them we are going to subtract. So here 3 minus that, it will be 1. So this in general will give us xn to power 1, then plus n out of 2 xn squared. So to candidates, whenever you are driving this and then you are to follow these steps, then you'll have no issue with Roman 3 and Roman 4. It is the same requirement. Now the next we are going to simply derive the Newton-Raphson'S formula for the reciprocal of a number, say n. So next is we are going to talk about derivation NRM for the reciprocal of a number n. Reciprocal of a number say n. So this one I'm going to simply have one example, and this one will be saying show that the Newton-Raphson'S formula, the Newton-Raphson'S method for finding the reciprocal of a number n is given by xn plus 1 is equal to xn into 2 minus nxn. So I want to show that the NRM for finding the the reciprocal of a number n is given by this. And here in our solution, we are going to simply say let x be the characteristic function. Here is the reciprocal of the number n, which you are seeing as 1 over n. Now here, how will the function f of x look like? So when we bring this one here, we're going to have a linear function, and when you have a linear function, I believe you have issues when you are differentiating straight lines. Now here what we are going to do is, we are going to first bring this one here, and that will be nx equals to 1, then divide through by x, that will be n is equal to 1 over x, and this one n will now be equals to x to power negative 1. Now here we can have the function look like this. We can have maybe n minus x to power negative 1 equals to 0. Now this one is a better function for us to deal with, so we're going to say let now f of x be equals to n minus x to power negative 1. Now from this we can now differentiate. Now when we differentiate this, when I differentiate n, I get 0. When I differentiate x to power negative 1, I will drop negative 1 here. That will make this positive. So this will be x to power, after dropping you reduce the power by 1, which will be negative 2. Then we now we obtain the functions f of xn and then the first derivative at xn. So we are going to have f of xn equals to n minus xn power negative 1, then the further derivative at xn, and this one is the same as xn to power negative 2. Then we quote the Newton-Raphson'S formula, which is xn minus f of xn divided by the further derivative at xn, and this one is going to be xn minus. So f of xn here is going to be n minus xn to power negative 1. Divide this with the first derivative, which is xn power negative 2, and to mathematicians, this one we can bring it as xn minus, let me hope we can write this as x minus xn. Divide this, when I'm dividing by x, this one particularly divided by this, I can bring this up, and when it comes up, its power will become now power 2 when I bring this one up. And the next step, we are going to have xn subtracting. Now we can enter this one here first, because minus affects the whole of this bracketed. So xn power 2 times n, we have n xn squared. When I bring this, it will be minus. When I'm multiplying this 2, I have negative 1 adding up with the 2, so the total will be power 1. So this is simply xn to power 1. So this is what I get. Now when I try to enter that negative, we are going to have xn plus 1 giving us xn. This is minus n xn power 2. Negative and the negative will give us a plus xn. So I'll be having xn with xn, that is the 2 xn, then minus n xn squared, and at the end of the day we have our xn plus 1. Here what is common is xn, and that is xn into 2 minus, I removed 1 xn, so this is 2 minus n of xn, and this is for n equals to 0. So this is the Newton-Raphson'S formula for computing the reciprocal of a number n, just as brief as that. If a candidate uses x equals to 1 out of n and then says x is equal to 1, is going to get very, very funny results at the end, and you may not achieve the solution for that. So the best way was to try out this approach. So with that, I want to wish you the best with this video, and I welcome you to the next video, which will be more of now calculator work. So try to practice with those examples that I left. I remain Mr. Wandwali Joshua, RSS. So to all of viewers, always after watching these videos, always like our videos, subscribe. So when you subscribe, every time you open YouTube, you always see our videos, right from what we started with posting and what we continue posting. You can always comment so that we know how to make our videos better to help the students in this mathematics. Thank you.